We are here. It's on a Thursday. We're ready to go with a little bit of math for today. Of course, before we get to the math, got a couple things we got to get through first. We've got to get through Disney pins. Today, Mickey and Minnie, repping it hard, repping it for the team. Because one day Disney will open back up. I'm just saying, it's going to happen. I can't wait. So Mickey and Minnie are joining me today. We also have some wonderful squeezy mates again. And the hope is, of course, fingers crossed, we don't get any Astros players. We don't want cheaters here. So let's see, what are we going to get today? It's a player for the Marlins. Alfaro. An actual baseball player for your Miami Marlins. But it's not all for today. We got two squeezy mates. We got two chances at getting an Astro to throw. Let's see. What are we going to get today? Oh, no, we get a pretty good one here. Max Scherzer. He's pretty good. Pretty good pitcher. He's a pretty good little keychain to end up with. They can go sit up here with some of the other wonderful toys we've gotten as part of these lessons. Disney pins, of course. Open something up? Yes, naturally. Oh, quotes of the day. Our throwback quote of the day comes from Wednesday, March 18th. If stupid could fly, your name would be Jetty McPlaneface. Jetty McPlaneface. And for today's quote, mirrors cannot talk. Lucky for you, it can't laugh either. All right. Our quote of the day is set up here, right behind the whiteboard. Again, today, because we finished up all of the material that's on Ingenuity, we're going to do a little bit of review. So we're going to jump into that right now. So get ready for a little throwback, hopefully something you're really familiar with, and something that you're going to be really, really strong with, especially going into next school year. All right now, Michael Scott, DJ Kitty, and of course Mr. Rogers. Pay attention. This is going to be on the quiz. And we're back, ready for a math lesson, a little review over simplifying polynomials. Okay? And today's going to be a little bit longer of a lesson to make up for yesterday. Sorry, yesterday's video did not get out on time. I do apologize, but we're going to make it up with a little extra math time today going into our weekend. We're going to talk about standard form first. Remember, for polynomials, standard form just means that we're ordering our terms of our polynomial expression based off of the exponents of the variables. And as we write our polynomial in standard form, remember we're going to be writing them from the largest degree to the smallest. Degree of the monomials that make up the polynomial expression. So looking over here, we have x squared plus 64 plus x plus 7x to the third power. That's a fine expression. There's nothing wrong with that unless we're asked to write it in standard form. If we're asked to write it in standard form, we've got to rearrange this so that our variables, exponents, are in decreasing order. So take a look at my terms. I find the one with the largest exponent, in this case, 7x to the third power. Be the first term of this expression. Then x squared, and x, and then our constant, 64. The same value in both expressions, just rewritten a little different way. Then over here we have a similar polynomial expression, but we have extra variables here. Not just one variable, not just one letter in our math problem. We've got two. So we're still going to be basing or writing this in standard form using our largest degree to smallest degree, but we're going to take into account in this particular expression our last term here, negative 7x squared y squared. The degree of that term is not 2. It's going to be 4. Why is it 4? Well, since x is squared and y is squared, we add the exponents together for the variables to get the degree of the term. So that's going to be the first term in this expression. I have to carry the sign with it. So negative 7 is the coefficient for x squared, y squared. Now I've got 2 terms that have an exponent of 3. I'm going to write them in alphabetical order because I like a little bit of order. I mean, it's a very algebraic way of thinking. You know, everything comes to its logical conclusion. So you have negative 7 x squared y squared minus x to the 3rd power plus 5y to the 3rd power, and then our constant at the end of the expression. Again, all we're doing is rewriting the polynomial in standard form. Real simple. And it's important to be able to do this because some expressions aren't already simplified for us. Sometimes we have to actually combine like terms to be able to simplify a polynomial expression like we have over here. We have 8x squared minus 12x plus 4 minus the quantity 3x squared plus 5x minus 1. Now, we can't just put all these numbers together because we don't know the value of x yet. And since we don't know the value of x, what we can do is combine terms that have the same variable and the same exponent with that variable. I'm going to use a little property here real quick. It's one of my favorites. Say it with me. Ready for 3, 2, 1. We're going to use the distributive property because I'd much rather add than subtract. I'm going to distribute that negative 1 into the parentheses. And now I'm just going to rewrite this expression with like terms together. I'm going to start with the term with the largest degree, in this case x squared. I've got 8x squared minus 3x squared plus negative 12x minus 5x plus 4 plus 1. All I'm doing is reordering this polynomial so that the like terms are together. Now I can add and subtract the terms that are in the parentheses because they are like terms. So 8x squared minus 3x squared, or subtract the coefficients, leave x squared alone. We have 5x squared plus, we have negative 12x minus 5x. It's really easy to think to yourself, well, I see 12 minus 5 has got to be 7, right? Remember, this isn't just 12, it's negative 12. For subtracting, we've got to get smaller. So negative 12x minus 5x is negative 17x. Come to our constant at the end, 4 plus 1 is 5. We're able to combine like terms and simplify the polynomial expression pretty simply. We'll be right back. We're going to do a little more math. Don't worry. Again, we're not going to cheat anybody out of math today. We're going to work with some polynomials in just a second. Be right back. And we're back with a brand new board with new information on here, a new topic. We're talking about multiplying now. Not just adding or subtracting polynomials together or monomials together to form these polynomial expressions. But we're going to multiply different polynomials and kind of talk about just different ways we use that. One example, multiplying a monomial times a polynomial. Where a monomial just means a polynomial with one term, which we have here, 3xy, being multiplied times the quantity 2x squared plus xy plus 3y squared. All we have to use is our good distributive property here. We're going to distribute 3xy. I'm not going to use this marker because it's a little bit dead. I'm going to try a different one. How about, feel good about this one. Feel a little stronger with this. There we go. We're just going to distribute 3xy to each term in this polynomial. So 3xy times 2x squared. We multiply the coefficients together. 3 times 2 is 6. X times x squared is x to the 3rd power. Y. Plus 3xy times xy. 3 times 1 is 3. X times x is x squared. And y times y is y squared. Last but not least, 3xy times 3y squared plus 9x y to the third power. Again, all we're doing is just multiplying the polynomial times the monomial. Really simple stuff. Things you've been doing since elementary school. Now, multiplying binomials together, we have really two options for the way we can think about this. We can think about like the whole distributive property, but we're going to throw it back to my days in Algebra 1. We talked about the FOIL method. The FOIL method really is just an acronym to help us remember that if I'm multiplying two binomials together, I've got to multiply the first term in each binomial times each other first. The 3m times 5m will be 15m to the second power. Then I multiply my outside terms together. 3m times negative 6, negative 18m. My inside terms get multiplied together. 4 times 5m plus 20m. And finally, the L for last terms. 4 times negative 6, which is negative 24. We're almost done here. I don't think we're quite simplified. I see some like terms here right in the middle. Negative 18m and 20m. We can add those together. We'll end up at 15m squared plus 2m minus 24. And finally, we're going to multiply a binomial times a trinomial. Here I've got the binomial 4z minus 3 times the trinomial negative 2z squared plus 7z minus 5. Now, it's a lot of math going on here. A lot of numbers, a lot of variables, but it's okay. We're going to use our super distributive property here to help simplify this down a little bit. All I'm going to really do is multiply 4z times everything in the trinomial, and then multiply negative 3 times everything in the trinomial. So, 4z times negative 2z squared plus 7z minus 5. And then negative 3 times negative 2z squared plus 7z minus 5. We've used our super distributive property. Now it's just time to use the good old distributive property. Thank you, Mr. Carter, once again. I'm going to distribute 4z to each term in the trinomial. Multiply together. 4z times negative 2z squared is negative 8z to the third power. 4z times 7z plus 28z squared. 4z times negative 5, negative 20z. We move over here. Negative 3 down gets multiplied times everything in those parentheses there, everything in the trinomial. Negative 3 times negative 2z squared plus 6z to the second power. Negative 3 times 7z, negative 21z. Negative 3 times negative 5 plus 15. We've got an elongated polynomial here. We can simplify it, combine like terms. We'll start with the term with the greatest degree. That's negative 8z to the third power. Now go to z squared. I've got 28z squared and 6z squared. We add those together, we get 28 plus 6. Use your fingers if you have to. It's totally fine. Yeah, 34z to the second power. Negative 20z minus 21z. Again, got a negative number minus something, so we're getting smaller, getting more negative. Minus 41z plus 15. There we go. We've multiplied different polynomials together. It's really a lot like what you did way back in elementary school when you were learning multiplication. Just expanding on it, putting it into a bigger algebra world focus. It's pretty awesome. Be right back. All right, so we've added and subtracted polynomial and monomials together that were in polynomial expressions. We multiply polynomials together. There's another mathematical property here I'm forgetting. That's right, it's on the board. I should just pay attention to the board. Division, we're going to divide so our polynomials here, a polynomial by a monomial. Wow, that looks intimidating. There's a lot of stuff going on up here. We've got 14x to the 6th power, y to the 3rd power, minus 49, x to the 5th power, y to the 9th power, all divided by negative 7, x to the 4th power, y. Now, there's a lot of mess going on up here. But we can make this look a lot easier with really just one simple mathematical practice. I'm just going to rewrite this in a format that is equivalent, but might be easier to use. We've got x, or 14x to the 6th power, y to the 3rd power. I'm going to go ahead and divide that by negative 7, x to the 4th power, y, plus negative 49, x to the 5th power, y to the 9th power, divided by negative 7, x to the 4th power, y. And now I've got something that should be a little easier to work with, a little easier to manage. Because we can simplify this fraction right here just using what we know about division for the coefficients and what we know about our properties of integer exponents. 14 divided by negative 7 is negative 2. X to the 6th power divided by x to the 4th power, we just subtract the exponents. That's x to the 2nd power. Y to the 3rd power divided by y. It's y squared. Plus, now I've got negative 49 divided by negative 7. But just like multiplication, when we're dividing two negative numbers, we know that the quotient is going to be a positive number. So negative 49 divided by negative 7 is positive 7. X to the 5th power divided by x to the 4th power, x to the 1st power. Y to the 9th power divided by y. It's y to the 8th power. Should be over here to the other problem. Our last one of the day. I know our time is drawing short already. I feel like we just started. Now we got 15x to the 5th power minus 35x squared plus 20x divided by 10x to the 4th. Now it's not a binomial being divided by a monomial. We've got a trinomial. Do you think that's going to change how we approach this problem? Of course not. We're simply going to rewrite this in an equivalent way. We'll make it easier for us to work with. So I'm going to rewrite this instead as 15x to the 5th power divided by 10 x to the 4th power plus negative 35x squared divided by 10x to the 4th power plus 20x, I'm going to write underneath this, divided by 10x to the 4th power. Now I've got three simple division problems here. Our way to simplify each of the monomials. We'll be able to have our trinomial divided very, very easily. So again, coefficients first. 15 divided by 10. Well, 10 doesn't go into 15 evenly, so we're just going to have to reduce that fraction. 15 divided by 10, well, it's got a greatest common factor of 5. I could rewrite that as just 3 over 2. X to the 5th power divided by x to the 4th power, x to the 1st. Since x is has a positive exponent, it's going to stay in the numerator of the fraction. You don't have to write that, but it's an understood one. If you want to write it for yourself, more power to you. Our next term, we got plus negative 35x squared divided by 10x to the 4th power. Well, we've got a negative divided by a positive. That tells me the term's going to be a negative term. 35 divided by 10, wow, again, it doesn't make a happy integer. What are we going to do? Well, that's what we just did right here. We're just going to reduce the fraction. 35 and 10 have the same greatest common factor as 15 and 10, greatest common factor of 5. So 35 divided by 5 is 7. 10 divided by 5 is 2. Now I've got x squared divided by x to the 4th power. Now if we do that, we end up with x to the negative 2nd power. And we know that for simplifying a term, we don't want to have a negative exponent in the end. So the way we can write that and end up with a positive exponent is to put that in the denominator. So we have so far 3x divided by 2 minus 7 over 2x squared plus 20 divided by 10. Oh, thank goodness, a whole number. Oh, we're waiting on one of those. 20 divided by 10 is 2. But, x divided by x to the 4th power. I thought we were going to have, man, I got excited for an integer. We really have is 2 divided by x to the 3rd power. Are these like terms? Absolutely not. So is there anything else that we need to do when it comes to simplifying this polynomial expression? No, we're done. That's it. Just like that, easily able to work with polynomial expressions. Now hopefully it's going to make things easier as we continue working this year, whether it's with our quadratics right now, whether it's exponential functions, which is coming up next. Get excited. Very relevant in the news today. But again, knowing our rules, knowing the simple tricks, the simple ways to compute makes life a lot easier. Have a great weekend. Monday we'll be back, new video for sure. Mickey, Minnie, anything else? No? Mickey. A little confused right here. It's all good. Y'all have a great weekend. We'll see y'all next week.